All right, so we get started today. We want to look at a couple of word problems together. And here's one that's got a little bit of a twist on that age type thing we've been talking about. Because normally we have two unknowns, and then they're compared to either traveling into the future or back into the past. This one's just a little bit different. And when I think of different, I think of Michael. So, Michael, go ahead and read this problem for us, if you would, sir.
In 5 years, Brandon will be... Bob will be twice as old as he was 3 years ago. How old is Bob now?
All right, those junior hires upstairs are shaking the ceiling, which is shaking my projector. So I'm getting dizzy watching this. But yeah, so here we don't have multiple unknowns, really. We just have one, and it's Bob. And we don't know how old Bob is, so class, we should call that X. That's Bob. That's Bob right now. But it actually describes Bob right off the bat. We time travel before we even start the problem, class. It says in 5 years, so we're going into the future right off the bat, in 5 years. How would it represent Bob's age in 5 years, Michael?
X plus 5.
X plus 5. But then it says Bob's going to be twice as old, and it's not comparing him to anyone else, it's comparing to himself in another time. As old as he was 3 years ago. So we not only have Bob now and future Bob, but class, we also have past Bob. 3 years ago Bob. How would we represent 3 years ago Bob? Genesis? X minus 3. So we have one unknown represented three different ways here. The question is, how would I set up the equation? What do you think, Michael?
Let's go with X plus 5 equals X minus 3 times 2. I'm going to go with that.
I like it, other than I would have put the 2 before the X minus 3 instead of after. How many were thinking the same thing that Michael said approximately? It says, in 5 years, Bob. So not the X Bob, but the X plus 5 Bob. That Bob, okay? That Bob, X plus 5, will be, so there's the equal sign that Michael picked up on, twice as old, so 2 times something, twice as old as who? As he was 3 years ago, past Bob. Future Bob equals twice past Bob. Questions on how we arrived at that equation. And from here we simply solve. Brandon will distribute to get
2x minus 6.
And then we should do what, Maddie? All right, so apparently right now, which is what the problem asks, it says how old is Bob now? Class, apparently Bob is 11 years old right now, which means future Bob is going to be 16. And past Bob would have been 8. And future Bob will be twice as old as past Bob. But we're concerned with right now Bob. And right now Bob is 11. Questions on this word product is a little different, but the same basic idea of setting up your columns in the chart or setting up the different sections and then interpreting exactly the way the problem reads. Questions on this one? Let's take a look at another problem here. There we go. All right, and go ahead and read this one for us, if you would. Abby.
A high school sold 240 tickets to a home basketball game. Adult tickets cost $3 and child tickets cost $2. If the school made $570 in ticket sales, how many adults attended? Children? it says how many adults attended, and then goes, children?
Yeah, meaning how many adults attended, how many children. No, it was actually the fact that it suddenly shook really violently as little children came stomping down the stairwell. I was like, well, there it goes. All right. Anyway, so how many unknowns do we have here, Abby?
2.
2, and they are?
Adult and children.
Adults and children. And I don't know how many adults. I don't know how many children. But I do know how many people came total, Abby.
240.
And I said before, if we have 2 unknowns, and we know the total of the 2 unknowns, one of the unknowns, Abby, should be
X.
And the other?
X plus 1.
Uh-oh, that would be consecutive numbers you're thinking of.
Oh,
Someone else
Y.
remember?
X
Why?
plus 2.
The total minus x. Make sure that's in your notes. Maybe write it a second time to help you remember. If you have two unknowns and you're given a total, represent one unknown as x and the other as total minus x. I've got another strategy tip for you. In a problem involving differing values like we have here, right? Adults and children aren't paying the same price for, well, really the adults are paying for all the tickets is how it usually works, but the adult tickets and the child tickets, they don't cost the same. My recommendation is going to be, in an event like that, let the bigger value be the x. So you might want to jot that down as well. If you're given the choice, which we are here, either of these could be x, the other total minus x. But let's let the bigger value be represented by x. So obviously the bigger value class is for an adult. Let's let the adults be x, and therefore back to Abby, the children would be
Y. And 240 minus x.
total minus x. There we go. And this represents the number of adults and children who came to this basketball game. Okay, so we have x adults, 240 minus x children coming to the game. Not only do we have differing numbers of adults and children coming, at least we assume it's different, I guess it could be 120 and 120, they also have to pay different prices for their tickets. Adults class pay $3 a ticket. Children pay, or else their parents pay $2 a ticket for them to get in. Again, oftentimes we'll see the number is where the unknown will be, the values will be specified. We will see problems later where the values are unknown, but the numbers are specified. But one of these, either numbers or values, will have to be specified. What did I say we're always going to do with these two columns? The number of each and the price of each. Audrey? We're going to multiply, because if I know that a certain number of adults came and they all paid $3 a person, I could find the total money that was spent just on the adults getting their tickets. Similarly, if I know how many kids came and I know they paid $2 a piece, I could tell how much money that the school made off of all the kids who came to the basketball game. So how would I represent all the money that was paid for adults to attend this basketball game, Kendall? 3x. How would I represent all the money that was spent for children to come to this basketball game?
2 times 240 minus x.
2 times 240 minus x. If we wanted to distribute right there, we could, or we could wait till later. Really doesn't matter. But this right here is money. It's a lot of money. It's hundreds of dollars, presumably, off the adults. This here is money off of all the children who came, presumably hundreds of dollars. And if we take all the hundreds of dollars off the adults and all the hundreds of dollars from the kids, what's it going to add up to? Genesis? $570. So what should my equation be?
3x times 2.
So we're going to multiply the adult money by the child money to get the total money? Total implies addition. So let's add the money from all the adults and all the money from the children to get all the money that the school made.
So 3x plus 2 times, can I go ahead and combine it?
We can go ahead and distribute right now.
480 minus 2x equals 570.
There we go. Take all the money from the adults, all the money from the kids, we go ahead and distribute. That's going to equal all the money that comes in all together. Money plus money has to equal money. Make sense? At this point, to solve pretty straightforward class, we'll combine our like terms to get just x. We'll ditch the 480 as a negative to get, and apparently how many adults came to the game? Apparently 90 adults came. How many kids? Well, subtract the 90 from the 240, that's 150 kids. Let's check. Every adult was supposed to pay how much money? $3. How much would that be? 270. Each kid was supposed to pay how much? $2. How much is that? 300. Does that add up to the 570 it said? Yep. So the problem checks out, and it said how many adults and then how many children, so we want both answers here. Questions on this? Are you starting to see a pattern that's reliable in using number of each, value of each, and then all the money put together gives you your equation? Questions? All right. Well, we'll look at more of those in the days ahead. For now, if you would turn your textbooks to page 115, where you did 1 through 11, the teal problems. 1 through 11, all the teal problems. We began looking at a new type of equation yesterday. What type of equation did we start working on, Audrey?
Rational.
I'm sorry?
Is it rational?
Not rational equations. We worked on those a while back, those equations with fractions. Think leftists? Really woke people? The squad? AOC? Class? Radicals. There we go. Radical equations. I'm not trying to be political here. Yes, I was. All right, radical equations. And what is a radical equation, Audrey?
Has a radical in it.
And it's an equation. Yep, an equation with a radical in it. Good. Or more specifically, where the variable is in the radical, would be a radical equation. And we said the key steps to solving radical equations. Class, 2 key steps. Say them with me. Isolate the radical, square both sides. We need to say it a little faster, though. We're putting Abby to sleep. Let's try it again. Class, 2 key steps. Isolate the radical, square both sides. Again?
Isolate the radical, square both sides.
It wasn't loud enough. Abby's still falling asleep. Let's try it again.
Isolate the radical, square both sides.
All right. And so the nice thing, I guess, maybe insulting thing, on the homework, they isolated the radical for you every time. So on every one of these, all we had to do was square both sides. So on number 1, when you square both sides, Abigail, what do you get?
138.
Well, I didn't ask for the answer just yet. I just said, what do you get when you square? But she was asleep when I asked the question.
X plus 6 equals 144.
There we go. And then, of course, all you have to do to solve after you've isolated the radical, which they did for us, and squared both sides, which Abby did for us, is solve. And we subtract the 6, and we do get what for our answer? 138. Number 2, same thing. Isolate the radical, square both sides. What do we get for our answer this time? Brandon?
4. No,
Number
that's
2.
an 11. That's an 11.
How about 11? I like 11 better. Let's go with 11 for our answer. Number 5, what do we get for our answer, Maddie? 87. Number 9, we've already got the radical isolated. When we square both sides, though, we are squaring a square root. And Audrey, when we square a square root, we get the... So I just get...
X plus 3.
But on the other side, I'm squaring a binomial. So we don't just square the first and square the last, class. We square the first, square the last.
Multiply and double.
Don't forget the multiply and double. So what do I get on the right-hand side here, Genesis?
X squared. 9. And 6x.
There we go. And all of a sudden now what started off as a radical equation has turned into, class, a quadratic equation, specifically a complete quadratic. Good, Brandon. We're on the complete quadratic equation, Kendall. I want to start by setting the equation equal to 0. And what do I get as I set it equal to 0?
0 equals x squared. Positive 5x.
Good.
Positive 6.
And of course we know then we're going to want to factor if we can. Of course we could use the formula. I would not want to complete the square, not with that odd number right there. But what will we get for our 2 factors here, Kendall?
X plus 2 and x plus 3.
And we set them both equal to 0. Outer inner does check. We get what 2 possible answers for x?
-2 and -3.
But I told you that when you solve a radical equation, if there are multiple radicals, which you haven't seen yet, we'll see those today, or if there's multiple roots available, make sure you check that one of those roots, or possibly both, are not, class, extraneous. Good. Now Abby's awake and Michael's asleep. Extraneous roots. And it's a sibling thing. And so let's check our roots here, Michael. If we have a -2 plus a +3, that gives us...
1.
And the square root of 1 is?
1.
1. And -2 plus 3 is?
1.
1. Does -2 check, class?
Yes.
Yes. Let's try -3. What's -3 +3, class?
0.
Square root of 0?
0.
-3 +3?
0.
That one checks as well. No extraneous roots here. Both answers check. How many have both answers checking? -2 and -3 for number 9. Questions on number 9. Let's take a look at number 10. And again, they've already isolated the radical, so I just have to do the next step, Genesis, which is to isolate the radical, class.
Square both sides.
Square both sides. That's the 2 steps we need to have memorized. What are they, class? Isolate the radical, square both sides. Again, isolate the radical, square both sides. You'll be saying it in your sleep, or as you're waking up in the morning. Anyway, so Genesis, they've already isolated the radical. What do I need to do? Square both sides. And when you square a square root, you get the, to get, of course, over here I'm squaring a binomial. 3 steps again, Kendall.
Square the first, square the last, multiply double.
To get?
B squared, and then positive 9, and then positive 60.
All right. And again, they get the quadratic. So again, set it equal to 0, Audrey.
Move 40 as a positive, and you get b squared plus 10b. You move the negative 7 over as positive, you get positive 16.
All right. And then we see if we can factor this. Can we factor it, Maddie? What do we get?
B plus 8 and B plus 2.
B positive 8, B positive 2. Outer inner does check. All equal to 0, 2. Possible roots here. What are they, Brandon?
Negative 8 and negative 2.
Negative 8 and negative 2. Let's check them both. Let's start with the negative 8. What is, be careful here, negative 4 times negative 8, class?
32.
Positive 32 minus 7.
25.
Square root of 25?
5.
5. What is negative 8 plus positive 3, class?
Negative 5.
Ooh, does the negative 8 check?
No.
No. That's an extraneous root. That means the negative 2 should work. Usually they will not both be extraneous, but let's just make sure. Class, negative 4 times negative 2.
8.
Positive 8 minus 7.
1.
Square root of 1.
1.
Negative 2 plus 3.
1.
That one checks out. That's what I expected when the first one went extraneous on us. How many have the negative 2 checking and the negative 8 extraneous? All right, questions on this? Questions? All right, let's go to number 11, where we're going to square the square root, class, to get z minus 4, the radicand, and we're going to square the binomial, Abby, to get,
Z squared negative 12 z positive 36.
and of course we're going to set it equal to 0, bring the z class over as a negative to get negative 13z, send the 4 over as a positive, get positive 40. We'll backwards FOIL z and z, signs class, both negatives by 40.
8 and 5.
8 and 5 will give you the negative 13z from the outer inner. So 2 possible roots for z here. What are they, Brandon? 8 and 5. And let's check them both. The original quadratic was the square root of z minus 4, all equal to... Where'd it go? There it is, z minus 6. Let's try the 8 first. 8 minus 4, class. 4. Square root of 4? 2. 8 minus 6? 2. 8 checks. 5 minus 4, class.
1.
Square root of 1? 5 minus 6?
Negative 1.
Ooh, thoughts?
No.
Doesn't check. And again, squaring creates extra roots, extraneous roots in many cases. And that's what we saw here. So really of the 3 of these that we did that had multiple roots, the first one both checked. After that, only one of them checked. Was anyone perfect? You went 6 for 6 on the homework. How about 5 out of 6? You just missed 1. All right, are there any questions at all on the homework? Do 13 and 14 at your seats. 13 and 14 at your seats. Thirteen and 14. first one, a couple ways we could go here to get my two answers. How many did get 5 and 15 as your two possible roots? Okay, how many did the factoring method? Right. Anyone complete the square? I think it lent itself toward that. Anyone use the formula? Okay, any of those would work. And we try the 5. That gives me what? 10, 6, 16. Square root of 16 is 4. And then 5 minus 9 is negative 4. So that one's going to go extraneous. The 15 should work. Double 15 plus 6, square root. And then 15 minus 9 is. So sure enough, the 15 checks. How many had the 15 checking with the 5 being extraneous? Good. Looking at the next one, we square class, we get.
2, 17.
Thank you, Brandon. Someone besides Brandon, we squared here to get.
A squared positive 14
Okay, that was much more what I was looking for when I said class the last time. Thank you. All right, we set it equal to 0. We get the m squared positive 12m when we make this negative. Positive 32 when we make that negative. Yes, I see what they are. So for the 32, split that up into 8 and 4. The most natural way to split a 32 based on what we memorized as kids in our times table. So two possible answers for m.
-4,
-8, -4. How many have those two possible roots? All right, questions? And then from there we plug in the, by the way, I know because there's an understood positive here, I can only get a positive, right? If I put a -8 with a 7, that's going to come out negative, isn't it? Extraneous. Shortcut. All right, the -4 should work then. 2 times -4, -8 plus 17, square root of 9, 3. And of course, -4 plus 7 is 3. And that's a good way to check. Now, will that work all the time? No, because you may get two answers that look like they both check. None of them would give you a negative, but that's one way to rule out an answer very quickly. If it would give you a negative and there's not a negative in front of this radical, you already know which answer it's going to wind up being. And for some reason, they'll usually give you the negative in front of the radical. So there we go. Questions? How many got that answer? All right. Any questions at all on what to do when there's only one radical in the problem? Feel like we got that? All right. Next thing in your notes, two radicals in a radical equation. We'll write this down. If you would, the square root of x plus the square root of x plus 5 is equal to 5. Square root of x plus square root of x plus 5 is equal to 5. You might recall yesterday when I had you write down your steps, I didn't have you isolate the radical, even though that's what we generally say. I gave you a little caveat in brackets is what we ended up doing to it. We said isolate the biggest radical. Of these two radicals, which one's bigger and uglier, class? The x plus 5. So you want to isolate the ugly one. This little one doesn't look too bad. So we're going to move the little one over to the other side. Okay? Little one doesn't scare me quite as much. Sometimes little ones are very scary. How many of you have ever worked in your church nursery? Little ones can be very scary. But anyway, we move the square root of x over as a negative. Now we've isolated the biggest radical. Now, class, we square both sides. Isolate the radical, square both sides. In this case, it's isolate the biggest radical. Square both sides. And of course, when we square a square root, class, we get the radicand. So on the left side, we just get x plus 5. On the right-hand side, we have a binomial. 3 steps, not 2. When I square the first, of course, class, I just get. When I square the last, I am squaring a square root. And when you square a square root, you get the radicand, which is x. You also always get a positive when you square the last. You're doing this with me at your seats. And then we have to multiply and double. 5 times 1 is 5. Doubled is 10. And I said keep the sign and keep the letters. Well, here the letter is a square root of x, if you will. It's a radical, right? Or you could say 5 times -1 square root of x is -5 square root of x. Double is -10 square root of x. Questions on that? And you notice we still have a radical. So guess what we got to do? Go back to step 1 and do it all over again. Step 1, class, was to isolate the radical. So we want to isolate this term right here. Thoughts on how to isolate that? I could knock off the x's first of all, right? Because I have an x on both sides. They match, they can be crossed out. I also could get rid of the 25 or I could double switch to avoid the negative. We're going to let Maddie, what do you want to do? You want to double switch. So let's bring the negative 10 squared of x over to get a 10 squared of x. And as a general rule, I don't like squaring negatives, just in case somehow that messes with the math. Strange things can happen sometimes. And let's bring the 5 over as a negative to get 20. Of course, we haven't really isolated the radical yet. We're not quite ready to square both sides because we still have to, class, get rid of the by. To get the square root of x isolated is equal to 2. And so what do we get when we, now that we've isolated the radical, square both sides? X equals 4. Notice we had to repeat the process. Isolate the radical, square both sides. Isolate the radical, square both sides. And we're done. We should check though, shouldn't we? What's the square root of 4? 2. What's 4 plus 5? Square root of 9? 2 plus 3 equals 5? Yep. And so 4 is my answer. Questions on this? We haven't seen one like that before. Questions? And we need more time to copy it down. I'm going to leave it up there for a little bit. Go and write this down if you would. The square root of x negative 7 minus 7 is equal to the square root of x. Square root of x negative 7 minus 7 equals the square root of x. I see equation. I see radicals. I call this thing a radical equation. Good, Audrey and Kendall. And so radical equation. What's my first step, class? Isolate the radical. Specifically, isolate the biggest radical if there's more than one. You could argue we've got a radical isolated, but your life is going to be easier. Again, I'm a lazy mathematician. So what I'm teaching you is the easy way. Easy way is isolate the biggest radical. What easy step could I do to isolate the biggest radical, Michael?
Add 7 to both sides.
I add the 7 to both sides, or move it over as a positive 7. So that square root of x plus 7. Now the big radical is isolated. So that when I now, class, square both sides, the big radical vanishes from its radical state. It is only now just x minus 7, just the radicand left. But on the right-hand side, 3 steps, not 2, class. What do I get when I square the first, anyone? Because when you square a square root, you get the radicand. Of course, when I square the last, that's easy, class. Positive 49. What about when I multiply and double, Kendall? Good. Positive 14 times the square root of x. And once again, class, we've got a radical. So now we need to go back to the beginning of the process and once again, isolate the radical. Genesis, how would I get this radical isolated?
Bring it over to the other side.
Okay, I could, though it's already positive. The reason Maddie did last time was it was negative, and by bringing it over, we got rid of the negativeness. So here, I'd actually rather leave it and move the other stuff. Does that make sense? Just, again, not wrong, though. We just wind up with a negative, and negatives are messy. I hate negatives. So, Genesis?
Negative x and pop. Negative 49.
All right. And so now my 14 times the square root of x stands alone. What are we left with over here, though, anyone?
Negative 56.
The x's cancel, so we just get a negative 56. Now, to isolate the radical, square both sides. The next thing I need to do, class? Divide 14 from both sides. That's going to give me the square root of x is equal to negative 4. Remember I told you I don't like squaring negatives? We don't have a choice here. Either the radical is going to be negative or the number is going to be negative. So some negative has to be squared. Let's go ahead and square both sides to get what for our answer? Michael?
16 equals x.
16 equals x. Now, this is not an always, but it's a really good clue that it's very possible. When you square negatives, you often get extraneous roots. That sign change that happens generates extraneous roots often, not always. There will be times you'll square negatives, the answer is not extraneous. You may occasionally get an answer that's extraneous and you didn't square a negative, but that's a big key that we really need to make sure we check. So, let's check our 16. 16 minus 7, class.
9.
Square root of 9.
3.
Minus 7 equals, what's the square root of 16? Does 3 minus 7 equal 4?
No.
It equals negative 4, doesn't it? So, nope, it does not check, but we don't have another solution to fall back on. So what's my answer if that's extraneous? There is none. My answer is simply no solution. And this will occur sometimes when you have multiple radicals in the same problem. So again, multiple answers, check because one of them, probably not both, could be extraneous. If you have multiple radicals, check the answer you get in some cases. We'll work somewhere, we'll get 2 answers still, but even if there's only 1 answer, still check, because it could still be extraneous and you could have no solution at all. Questions on this one? Page down, Genesis. Questions on either of these problems before you get a chance to try one yourself? All right, page 115, do number 20. We're there on page 115, do number 20. Pencils down even if you're not finished. How many started by moving the square root of n over as a negative? You isolated the biggest radical. When you squared both sides, did you just get n minus 4 on the left? And over here, square to get 1, square to get a positive n, multiply and double to get a negative 2 square root of n. How many got this? Again, 1 times 1 is 1, double that is 2, keep the sign, keep the letters. From here, the n's cancel. And since this was negative, I brought it over as a positive, sent the 4 over as a positive, get 2 squared of n equals 5. Now, I don't like making the fraction that's not the end of the world to divide by 2, and then square to get 25/4. Or you just go ahead and square as is. Now that the term is at least isolated, you get 4n equals 25, still get 25/4. You go back and plug it in on the calculator, you end up getting 2.5 plus, subtract the 4 from the 25/4 and take the square root. 1.5 equals 1? No, that equals 4. 4 doesn't equal 1. That's extraneous. We have no solution. Notice we didn't square a negative this time. That's often my clue, but you can't say, well, I didn't square a negative, I know it's going to check. No, always checking these radical equations. How many got the 25/4? How many then also realized it's extraneous and put no solution? I have questions on this. You've got just 4 problems for homework this evening. Page 115, numbers 17 to 23, the odd. Page 115, numbers 17 through 23, the odd. We'll take a look at all of those. tomorrow as we wrap up this section on radical equations. Have a wonderful rest of your day, and you are dismissed.